I will guide you through the second part of this seminar session, and I will talk about environment and package management for Python with Conda. Before starting and explaining to you what is environment and package management, it is important to first make sure that we all know the three basic terms to know what we are talking about. It is important to understand what is packages, dependencies, and environments. I'm sure you know most of these things, but still, just to be sure, you know that Python heavily relies on many external packages. You usually don't use basic Python to perform most of the operations, but you import different packages like NumPy, Pandas, scikit-learn, and many of the others. And important thing to understand about this package is that most of them are under very active development and get regular updates on a monthly or even on a weekly basis. Most of these packages also have dependencies. Dependency is just another package that is used by the higher level package to implement some of the functionality. For example, the scikit-learn package may require NumPy package to perform some of the computations to fit a logistic regression model. So then NumPy becomes a dependency of the scikit-learn package. And the tricky thing is that some packages may require different versions of the dependencies, and different versions of different packages calling for different dependency versions may create conflicts and may cause some problems. And I will talk more about that in my next slide. And then the last term we need to be clear about is environment. Environment is just a virtual machine that has a specific set of packages installed. And this concept is important to understand because this is a basic concept behind environment managers like Conda. A single computer can have multiple environments, and in each of these environments, you can have different versions of Python, different set of packages, and different versions of those packages. And this proves to be very helpful. So you may ask me, why is it exactly helpful? And why do we need something like that? Why do we need to manage environments and packages? Well, the need to do that comes from the fact that there are many common issues that you can face during working on the projects that require some coding. And trying to address these issues, people developed infrastructure tools like environment and package managers. Some of the issues you might face when working on different projects is that actually different projects may have very different requirements, both with regards to the Python itself and to the packages as well. For example, you may have a project that uses that downloads Twitter data first, and for doing that, you maybe downloaded a script that can do it with Python 2. But when you do the data analysis and you use packages that are only available for Python 3. So when you start jumping between these project sections, you need to completely reinstall all your software, including Python, including package versions. This is, of course, not something you would like to do. That's why it's advisable to use environment packages managers like Conda, because they allow you to set up environments with custom versions of Python and package versions. And then you don't need to reinstall anything. You just need to switch between different environments when working on different projects that have different requirements. Because of the constant update of the package versions and dependency versions, sometimes you may face conflicts, and packages require dependencies with conflicting versions. And sorting this out manually is a lot of work, and you would like some kind of an automated solution that can just look for the available package versions and install the relevant versions for you, such that you don't need to put too much effort into looking at that. Sometimes people also face other issues. Code was working yesterday, everything was fine, but you try it the next day and it fails. This may happen due to a lot of reasons, but one of such reasons could be that one of the packages that you use got updated. Maybe they renamed a function that was used by the package, or maybe they eliminated it completely or changed how it works. And you now have to look for it and try to solve this thing and rewrite the code snippet to make things work again. This, of course, can take a lot of time, and fixing the package versions in your environment is something that can help you to avoid this kind of issue and be sure that the code will not be failing tomorrow just because the new update of some of the packages has been shipped. And one final issue I also want to mention is that code can also produce different results on different machines. And of course, there are many reasons behind that. And if you've taken the business analytics and data science, you probably know the importance of setting random seed and making other precautions in order to make your code reproducible. But sometimes it's just because there are different versions of the packages. And you may face a case where a package that you are using in different versions does the same operation slightly differently. For example, in the pandas package, at some point, they changed the way they sort the data table after merging two data frames with each other. And of course, if you have different sorting, you may end up with very different results when training a model. And without knowing that, without that the pandas package has a different version on that machine or for that user, you wouldn't know that. And you would need to spend a lot of time on trying to understand why this happens. So this is just a brief overview of some of the issues you might face. And environment and package managers aim to help with these issues by setting up environments with fixed versions of different packages, by resolving conflicts between dependencies when you install new packages, and helping to make the projects self-contained and reproducible because of that. Conda is one of the environment and package managers that is available out there. This is one of the most popular ones, and it's that popular because, first of all, it's free and open source, and it's platform agnostic, so you can use it regardless of the Windows, macOS, or Linux operating system. It works on all of them, and it works with the command line. So similar to Git, as Alona was describing its functionality, there is a possibility to work from the command line and typing the commands to interact with Conda. There is also a visual navigator to work with Conda, but it has a very reduced functionality. So I would really advise you here to work with the command line and don't be too much afraid of it. And another advantage of Conda is that it actually supports multiple programming languages, although, of course, it has been mainly developed for working with Python. You might say that it all sounds very good, but I was working in Google Colab before and didn't have all of these issues you are talking about. So why would I then care about Conda? To explain that, we need to draw a line between two different approaches to development, or two different environments in which you could do the programming. It is important to distinguish the web-based editors, which are these browser-based notebook environments like Google Colab, Kaggle, or Amazon SageMaker, where you work in a browser and you don't need to care too much about the hardware. And in that case, yes, you have a set of pre-installed packages. The Python is installed, many of the packages are already installed, and you don't need to do anything about that, but it is managed externally. If Google decides to update Python from 3.7 to 3.8, then you need to make changes in order to adapt all your projects to that. Or if you want to work with packages that are not included with Colab, you need to install them manually. And if there are any conflicts, you also need to resolve them manually. Using Conda to do that in this kind of web-based environments is difficult although it is possible, but it is too much effort. And environment managers like Conda were mainly designed for the software-based editors, where you edit your code not in a browser, but in a software application that is installed on your machine or on the cloud machine. And this is what you can do with editors like JupyterLab or Visual Studio Code or PyCharm. There are many solutions that are popular. And in that case, when you have this access to the machine, you can install Conda, and then you can make advantages out of using it to really set up different environments and take full control over the Python and package versions in different projects. Of course, it is your choice which stream to take here. And I know that many people use Google Colab and are quite fond of that, but I should emphasize that when working with browser-based IDEs like Google Colab, it is usually more suitable for short-term or one-person projects that are only based on a single notebook, or for demonstrating results like you can do with the final APA paper, where you just create a final notebook that has all of the main results. But for the actual development process, if it is long-term and if it is collaborative, it usually includes multiple notebook or script files, and for working in that kind of environment, using package and environment managers in a software-based editor is more recommended. And this is what many companies do in practice when they actually work on the solutions that get deployed in their own systems. Right, now that you know roughly what Conda is and what package and environment management is, I will tell you about the actual usage of Conda, how to install it and how to make use of it. Of course, first you need to install it. To do that, you simply download and install the latest version. Depending on your operating system, you can see the links attached. You should know that there are two versions of Conda, Mini Conda and Anaconda. Conda itself is a package and environment manager. Mini Conda and Anaconda are the high-level applications that have Conda inside. The only difference between Anaconda and Mini Conda is that Anaconda has a lot of popular packages that are already pre-installed, which occupies about 3 GB. And if you don't need that, and I think that you would probably want to start from scratch and install everything manually, because you usually don't need that many packages for your projects, you can then go with Mini Conda. But the functionality inside of that is the same. Once you have the Conda installed, you can interact with it from your command line. If you install Conda on Windows, then you get an application that is called Anaconda Prompt. You launch it, and this is a command line through which you can interact with Conda. If you work on macOS or Linux, then you already have a terminal app which you can launch. It looks something like that. And from that, you can interact with Conda using the same set of commands. The commands do not depend on the operating system. In your terminal, you usually see some messages like what was the last logging in the console, what is the name of your computer, what is the current directory that you are now in. You can ignore this for now. You can then just know that once you open the terminal, you can type in the commands to ask Conda to do something and then get output once it is done by Conda. Starting from the basics, once you have Conda installed, you can verify that it is actually installed by typing Conda --version. All Conda commands start with the Conda prefix. So when you type Conda something, you ask Conda to do something. And as an output, you get a message from Conda saying that the current version is actually 4.9.2. And this is how you go with all the other commands as well. Here on the slide, As a reference for you, I have also included the comments on how to update Conda. It doesn't update the packages, it updates the Conda, so the actual software that does the management, not the package versions. It is important to understand that. You can also see how to uninstall Conda in case you need to do it. Right, so now you have Conda, everything works. The first thing you probably would like to do is to create a new environment for you to work in. And to create an environment, you can use this command displayed on the slide here. You type conda create _name, and then you include the name of your environment. It can be anything like APA, my environment, whatever, it depends on you. After that, you can specify a version of Python. Here I specify Python equals 3.8 because I want 3.8 installed in here. And after that, you can also include the list of packages that you would like to install in this environment. If you don't do that, the environment will be empty, just base Python. And after that, you list the packages that you need to work with. In order to see the list of the environments that is already available, you can just type conda info _env and it will print you the list of environments you have already created. And of course, you can remove any environment at any point of time if you need that. Once you created an environment, the important thing is to understand how to work in this environment. And to do that, you need to be able to select an environment and switch between them. Switching environments is done with a simple command, conda activate, and typing the name of the environment. And in order to understand if you are located in the right environment, you should look at this first term, which is an environment indicator showing you the environment you currently work on. So you see here it's base of the root environment. This is where you start by default. And then if you type conda activate APA, assuming you have already created this environment, you will just see the updated indicator telling you that you are now actually working in this environment. Once you select the environment, you can then make different operations in each environment. You can install different packages and take care of that. In order to install packages, first, you need to make sure that the desired environment is active. In principle, you can also install packages not in an active environment, but in order to be sure, it is the simplest way to go about that is to make sure that you first select the environment you're interested in. And then you have different functionality available to you. In order to search for package versions, you can type in conda search and package name like NumPy. It will print you all versions of NumPy that are available in Conda, and you can install them. And to do that, you just then type conda install and package name. Optionally, you can also specify the exact version of the package. And then you just do it space separated list of packages in order to cover all of the packages that you need. Now, one nice thing about Conda is that you can also install packages from a file. So you can actually create a text file that looks something like that, just a list of different packages. You can specify versions. You can avoid specifying versions to try to install the most recent version that doesn't cause any conflict, and then just use a command conda install file and specify the file from which you install the list of packages you need. This is particularly useful if you want to share the list of packages that you want to be installed in an environment with your colleagues. The thing is that some of the packages might not be available in Conda repositories. In other words, if you type conda search package name and you don't see anything, most of the packages are of course included, but sometimes it can be that packages are not there. What to do then? In that case, the first thing you should do is to Google the package GitHub page find the documentation link, and then look for installation instructions. Most frequently, the installation instructions come in the form of command snippets, short blocks of code that tell you what kind of command you can type in the command line or in Python in order to install the package. And in a vast majority of cases, all ways to install packages will be covered by this tree that you see on the slide. You first try Conda install. If the package is not there, because it is not part of the official Conda repository, because maybe the developer was a bit lazy or didn't want to share this package there, you can try to install it from Conda Forge with this command. Conda Forge is a community-led Conda repository that is not official, but it is just supported by people who copy the package source files and store them there so that you can install them from here. And finally, if the package is not in either of these both locations, maybe because this is a very custom package that you yourself has developed and have not published it on Conda, nor on the community-led Conda repository, and it is only available on the pypy.org, then you can install it with Pip Install, which is a standard Python package manager. Usually, I would advise you to go from Conda install to Pip Install, because the lower you go, the less is the flexibility which Conda allows you to have when it tries to solve conflicts between different package versions, updates of the packages, and so on. The typical Conda workflow with the Jupyter Lab, if you would like to do it, is simply as follows. I wanted to show you a quick demo of that. So maybe I quickly start sharing my screen and show you what you can actually do with the Conda in a very quick demo. So you have a terminal, which looks something like that. I have already Conda installed on my machine. I can check if it is actually installed by typing Conda version. And you see here that the Conda version I have installed is 4.1. And then what I want to do is to create a new environment. So I just type Conda create upper Python equals 3.7, for example. Then it starts solving the environment and prints me the set of base packages it will be installing in my environment. These are just some basic packages that are needed for basic Python to work. I type yes and let it do the work. It takes some time because it basically downloads these packages and installs them in the environment. Now this environment is installed, so you can see some tips here. It already says that I can activate it. I can just type Conda activate upper, and I'm now in the upper environment, as you can see by this environment indicator. What I can do now here, I can type Conda install Jupyter Lab in order to install the Jupyter Lab package in the upper environment. I will not be specifying the version, but it is fine. And it will be installing this package for me. As you can see, this is the list of dependencies for Jupyter Lab. There are many. I will just agree to that because there are no conflicts. It doesn't say me that there are any warnings because of that. And I will just let it do the job until the package is installed. And after it is done, I again see that I'm located in the upper environment. And then just by typing Jupyter Lab, I can launch my notebook environment and let the Jupyter Lab start the Jupyter notebook in which I can work. It takes some time because my machine is not that powerful. Now you see it opens the Jupyter Lab, and I know that this is a Jupyter Lab in this environment. I can check that Python version is actually 3.7. This is because I specified Python to be 3.7. If I go to a different environment, I will have a different Python version in here. So this is roughly how you can work with Conda and Jupyter Lab.